Hello and welcome back to Decrement. This video is going to be a quick introduction to the C programming language. Hello world and compilation. To compile, run the name of your compiler -o hello.c. Compilation turns computer code that you understand into the ones and zeros or binary that the computer understands. To run, just type hello. This code down here prints hello world to the screen. Comments. // that's a single line comment, or / and asterisk on multiple lines is a multi-line comment. Comments are little notes to yourself about what the code is doing. Variable declaration. Declaration is making a variable exist. Its general format is type variable name, semicolon. Examples of types: char, short, int, long, double. C gives you no guarantee of the value that's in a variable if you only declare it. You also have to assign it a value. Variable assignment. Assignment is giving the variable a value. The general format is type var name equals value semicolon. Like the example below it, int x equals 5. Assigning multiple values of the same type on the same line can be done like the other example. Int x equals 1, y equals 2, z equals 3. Now all those variables are ints. Math. C supports the four main operators you're already familiar with: plus, minus, multiplication, and division. Also, the modulus. It's the remainder operator. It returns the remainder of a division problem. Int sum equals 2 plus 3, 5. Int diff equals 5 minus 3, 2. Int product equals 3 times 2, 6. Int quotient equals 8 divided by 2, 4. Int modulus equals 1 mod 3. The answer is 1 because you have a remainder of 1 when you do 1 divided by 3. Typedefs. You can give one of the types in C an extra name. General form, typedef, type, user type. So in this example, you give the int another name, number. Operation and assign operators. Variable. The general form is variable operator equals value. X plus equals 5. Read as add 5 to x. Examples of operators: plus equals, minus equals, times equals, divides equals, modulus equals. Increment and decrement in shorthand does something similar to the previous operators. Adds or subtracts 1 from the variable depending on operator. X plus plus, use the value in x and then add 1. Plus plus x, add 1 then use the value in x. X minus minus, use value in x then subtract 1. Minus minus x, subtract 1, then use the value in x. Be very careful when you use these as it could lead to unintended and hard to track down errors. Comparison operators. Has the couple you know from math: a greater than b, evaluates to true if a greater than b. A greater than or equal to b, evaluates to true if a greater than or equal to b. A less than b, evaluates to true if a less than b. A less than or equal to b, evaluates to true if a less than or equal to b. A few operators exclusive to programming. A equals b, evaluates true if a is equal to b. A doesn't equal b, evaluates true if a does not equal b. Logical operators. Joins together values that are true or false. Examples of operators: ampersand, and, evaluates to true if both values are true. Double bar, or, evaluates to false only if both values are false. Bang, or exclamation point, not. Changes a true to a false and a false to a true. If statements. Allows you to operate code under certain conditions. Else if allows you to take multiple different paths. Else can be used whenever if and else if above it has evaluated to false. In this example, you have the number 5. If it's less than 0, you print out negative. If it's greater than 0, you print out positive. And otherwise, it's 0. So in this case, 5 is greater than 0, so you'd print out positive. For loops and while loops. For loops are for a known amount of times where you want to do something over and over. While loops are for an unknown amount of times where you want to do something over and over. In the for loop example, for int I equals 0, I less than 10, I plus plus, that will print high 10 times. In this while loop, while counter less than num times, it prints high however many times counter is less than num times functions. Name pieces of code that have inputs and outputs. The general form is type function name, parentheses, type arg1, comma, type arg2, ... for as many arguments as you have. This example is an add function. You take in 2 integers and then you return their sum. C always calls the main function first. Functions have to be defined before they can be called. In order to get around moving functions around, you can forward declare functions before main. Forward declare means defining the first line of the function, then ending with a semicolon. Example with add, int add, parenthesis, int num1, int num2, close parenthesis, semicolon. Arrays, an ordered sequence of values of the same type. Unlike other languages, there's no way to access the array's length. In this example, you have a coins array where you have 11 pennies, 22 nickels, 33 dimes, and 44 quarters. And then you have the values of these currencies in the other array. You go through a for loop, and then when you do the coin sub-I or value sub-I, you're accessing that certain position in both array. So the first go through the loop, you're accessing the 0th position, so you're doing 11 times 0.1. When I equals 1, you're doing the second position, so 22 times 0.05, and so on until you total up all the money that you have. Structs, a collection of variables that has a name itself, and each variable collects have names as well. In this, you have a person struct that has a char star name and an age, and then you're defining that in the main function that the person has a name of Bob and an age of 25. Typedefing a struct. You can typedef a struct by doing the following. Typedef struct person, and then putting person after the curly braces. The typedef takes struct person and gives that type an additional name, the person, which is whatever you put after the curly braces. Motivating example. Exam dates and locations are something you never want to mix up. So in this first example, you have two arrays where you have dates and locations. The only thing keeping you from mixing up dates and locations is paying attention to when you type them in. And then, in the second example, you have an exam struct, where you build up one exam, and then the second exam. That example is incorrect. It should be exam1.location, exam1.date. It doesn't have exam1 for the location. Anyways, you build up an exam, you put them into an array, and then every element in your array is an exam, and you won't mix up the information at all. By the very nature of the structs, two pieces of information stick together. Pointers, a variable that stores the memory address of another variable. Declare a pointer, int star varname, semicolon. Assign a pointer, int star varname equals ampersand a, semicolon. Now varname holds the address of a. Value at address that pointer is holding, called dereferencing. Star varname, semicolon. That's the value of a. Just declaring a pointer without assigning a value does nothing useful. In this example, you have the number 2, you declare a variable, you declare a pointer to the number 2, and then you use the dereference operator to make num now equal to 5. Pointer to a struct. This example just shows that if you have a pointer to a struct and you want to access its variables or members, you can either put the pointer in parentheses, dereference it, and then do dot, or just go for the arrow and then access the member. Obviously, the arrow looks a whole lot cleaner. Final Flurry, malloc, and free. All this time, char star PTR was a string or collection of characters. If it's a collection, then are the following two equivalent? Char star s equals high, char t array equals high. No. Why any of these are different is out of scope. But there is one final way. Char star s equals malloc 3 times size of char. This asks for 3 bytes of memory from the computer. And then in the first slot, you put an H. In the second slot, you put an I. And then the third slot, you put the end of the string. And then when you're done with the memory, you free it, which gives the 3 bytes of memory back to the computer that you asked for before.
Segmentation fault, core dumped.